Good morning. This is UDACITY Project 2. Benjamin Ogunsade is the name. So this is my project plan divided into weekly plans, quarterly plans, and yearly plan on how I plan to achieve this. So I need to understand what's computer networking and what are cloud platforms. That was done last year, and now this year, with a good knowledge of networking and likes, now I can learn Azure Cloud. Now, for the weekly plans, these are the things I need to understand. And then for the monthly plan, I go into the project proper. So the things to be done for the continuous integration, you have to set up your cloud shell and also the GitHub actions. Then later we'll now move into continuous delivery using Azure, specifically Azure DevOps organizations. Then I do the documentations. And now first, this is the Excel presentation of it, and this is the Trello. This is the Trello account. This is my chart of how I intend approaching this project. So the things I need to do, I subdivided it into short, simple, achievable goals. Then those are in progress, and to what extent the project is achieved. Now, the next thing is just to have a track of the project. So the next thing now is to set up my Azure shell. I create my Azure account. I must have a Microsoft Office account. Then I have the necessary subscription. I must have a subscription with a group resource within which I'll create the application. Now the next thing is to set up my command line interface wherein I can enter my commands, and that I did. For that to be done, you have to create a cloud storage account, and that after that is set up, I select Bash as my terminal instead of PowerShell. I'm quite confident on the two. For the project, I prefer Bash. Now I make use of SSH keys. So I'm generating SSH key here in order for authentication to my GitHub, for remote authentication to my GitHub. So this is the command, then which was imputed. Now I recovered it using the scat command to spit out the on the command command line interface, the public key. So I copied it and I pasted it in my keys. There's a key section in my GitHub under settings wherein I store all the keys from my shells. So for this particular shell, I copied this public key with which it authenticates with the private key on the shell terminal. So next thing, authentication established. Now the two can communicate. The shell can communicate with my GitHub repository. Now I have to clone. Already I've created up a folder. I've moved all my files. So I've created the make file. I've created the requirement as text. I've created even the hello.py. You can see them all here. Hello.py, readme, test hello.py. I've created them already, and I've manually moved them into my GitHub. Now I need to clone it down into my interface, to my terminal. So I've cloned it, and this is the result. Then this is just to show the scaffold of the files contained in the project. This is my make file. I'll come back to it to explain what each command means. Okay, let me just do it straight up. So the make file comprises of 1, 2, 3 commands basically, and the fourth one which calls the first 3 commands. The first one is the pipe command, the pip install command, and also to upgrade it to the latest version. Then you have the pip install, which also installs the requirements for this particular project. So the requirements, we have the PyLint and the PyTest. The PyLint is for the linting, and the PyTest, this is it. It gives call to the PyTest hello function, and this is the lint. It lints the real code, which is the hello.py. So now, it is encouraged. One of the interesting DevOps practices to work in virtual environment. So we are going to create a Python virtual environment because we're trying to deploy a Python machine learning project. So at the same time, we'll source into it. So this is it. I created it, I sourced into it, and now I'm in my repo. My virtual environment. So at the same time, I navigate down into the project within my repo, and then business starts. Now, the local test. First, I make a local test to do my local test, I need to ensure that all the dependencies necessary for my app to run is installed. And for that to be achieved, I make use of the command called make all. The make all, which refers to this, the make calls for the make file document, and the all command there specifies the install lints test, which runs all these commands. So running them gives you all of this, so till the end. So that's completed. We had some errors while trying to run the command, and I just used this documentation to explain how to navigate around some of these errors. I won't go into this. So as this was completed, the next thing is, this is the final result. You have that the test hello was passed 100% because this command was launched by the test here. The test, after making the make all command, it also runs. The test is the last command it runs, and the test file, it specifies the hello test. So and once every of the functions there is correct, and it gives you 100%. Now to the test passed. So now the next phase is the continuous delivery on Azure. So some prerequisites need to be done. We were provided with a Flask starter code, which was cloned into the machine. That is, in short, I'm going to replace the original files that I was provided with. That is the 4 or 5 files here, 1, 2, 3, 4. I set my README. I'm going to replace them, and I also add more files. So I located this Flask file, and I cloned it, and it was added into the document. So this is a chart of how I got that done. That is, I cloned into the path, the Git location. I cloned into it. I listed what were the elements within that, and I have this. So I cloned into the document itself the particular, and I lifted it up. After lifting it, after cloning the Agile development with Azure, after cloning it, the next thing was for me to move it into my project. And once I moved it into my project, the specific files that I needed, especially the starter files, that's what I needed. So I cloned it and put it in my files, and that was it. So now once that is done, that prerequisite is done, having my files cloned within my command line, the next thing is to configure GitHub Actions. So what's the aim of GitHub Actions? So GitHub Actions serves as a platform for automatically building, and you can see at the top of my project you have this passing indications to tell you that the Python test works with GitHub Actions. So now I have to also create a new cloud session, that is a new cloud terminal, the Bash terminal. So on that, I source into my virtual environment and navigate into my project. Now I have to start the application. So the app.py is a document that was provided in the file that which I was cloning, the starter file that was cloned. So being a Python application, I run with Python. And doing that, this is the cloning, this is the sourcing into the repo, navigating to the project app, calling the app.py function, by running the Python file. It runs and it gives me, oh, there's no module named Flask. So this is an error to help. So I listed out the elements to see what's contained in the file, and that I listed all the files on the maker. I saw the app.py. So to correct this, I ensured my make all, because it was a new repo, a new session. I had to ensure my dependencies were installed by rerunning the make all. Having that done, then my Python command was able to proceed without error. So it proceeded and it's now running on the local host, the 127.0.0.1 on the port 5000. So now The next thing is for my local prediction. The local prediction is done using uh, the shell file, make prediction.sh, and a new cloud session. So this was run. Obviously, it runs into an error on the first trial because you need to give it the file itself. You need to give it an execution permission using the change mode plus X, which is for execution for the file. Then after you run it, and the predictions runs well, giving you the port number and the prediction code. So that's locally. So next is to run the remote prediction. So there is need to first deploy the web app. So now for the remote prediction, the web app, which we named my Flask ML web app, was deployed on the Azure portal in order to access it remotely. So I created a resource group within my Azure subscription, my Azure portal subscription, named Oba Nimi 234, and the runtime, I'm using a Python 3.7 version. So the Azure web app was run, and the result that was produced was this. So it first created a app, and this is in brief the final results. Have this URL with which I can access my app, I can view my app, and also the resource group was stated, deployed in central US, the Python version, the system is Linux, and the source path to my project. So now I advance. Now following this link, one can access the prediction page as sklearn prediction home. So the next thing is at the same time to run the make predict azure app.sh command in a second shell environment. Now, on running that, it also produces this prediction, which is correct, published on the port through the port 443. 443 being the HTTP S port. So this is a secured port. In short terms, it's referring to the Azure portal app that's already been deployed. So that's that. Because within this, the make predict Azure app shell document, you have to replace. There's a place where you need to replace the link. This link, you will need to paste this link within it. Okay, so I advance. So now, next we head to Azure portal to see the app that was deployed via the command we set here previously, web app, Azure web app up, specifying the name and so we go back to see two things were created. We have a service plan and a service and app service. So this is ready too. So this is the service plan called Leonardo, and this is the my Flask ML web app as the app service that was deployed. So the next thing, in as much as the app is running and the URL being accessible, now we generate this web app log tail. So it gives us everything, the most important information that it was successful and it's ready to serve request. So the next thing, after we have this done, the next thing is to run the low-cost file. So we run the low-cost file for 20 users at the rate of 5 and the time interval 20 seconds, and this at the same time was run thus, and we had a successful page. It was done successfully without errors. So the next thing is to configure in proper my GitHub Actions. So this can be done automatically using GitHub Actions. So GitHub Actions is on your GitHub page. You have where your code is, for which I'm reading this current README. You have this pane where you have called actions. So under actions, you could create a new workflow. After you create your new workflow, I named mine Python application test with GitHub Actions. So it was created. So this is it. So I'm creating it. I replaced the WML code. So it was replaced. There's a So it was replaced. There was one that was provided. So this is what I created, ensuring that the tabbing was respected. So I used a 3.8 version of Python, and it was pushed to GitHub, and both leads and tests were verified, and the test was passed, and the build was passed within 16 seconds. So the screenshot of it, and it was successful. This is it, even the LinkedIn. So that is done using GitHub Actions. So the next thing now is to do the same, that is using the Azure platform, the Azure DevOps organization platform. So Azure DevOps, to create a CI/CD, that's a typo to be corrected, the CI/CD Azure pipelines. So to do that, before anything is done, we need to verify that our predictions are still active. So we create a new terminal and session and quickly verify this, and we see this running. This will be running in as much as the app itself is still active. And mind you, the local one make prediction is on port 5000 and the other on port 443. So now the Azure continuous pass was done. So just a recapitulation of how I got into my Azure DevOps. So this is it. You type Azure DevOps in the search pane. It leads you there. You click my Azure DevOps organizations, and I made sure the visibility was private, and named it my Flask ML app project 2. So this was done. Then I clicked pipeline. But before I went to do this, I first configured the pipeline. I went into project settings here at the bottom left. I clicked service connections. I selected Azure Resource Manager, and then after that I clicked create service connection. So obviously I chose Azure Resource Manager. So I chose service principal automatic for as an authentication method, and then enable the build to run automatically upon any modification of the artifacts. So on the code. So now we made these following choices when we were creating the new Azure service connection. We created our current subscription, Azure subscription, and the scope level was subscription. The resource group was selected, which we had. The mobile enemy was the one selected. The service connection was project 2. This is the name I gave to it. And ensure you click the grant access to all pipelines so that there will be automatic pipeline selection. So this is a recap of what I selected. Now I have the service connection created here. So once the service connection is established in the Azure DevOps organization portal, so then I can deploy via CI/CD. I can deploy the Python ML Flask app. So configuring this, I go to pipeline. I create a pipeline. This is a link here to create the pipeline. So create pipeline here. Click pipeline connect. You select your GitHub YAML as a YAML file in order to select my project. It links me down to GitHub in as much I've done the authentications. I select Python to Linux web app on the configure, and the next thing is to create a name for my app, which I gave it the same name, which is my Flask ML web app. I validate and configure it. So automatically the YAML file is generated. So the YAML file is generated, and the resources were automatically configured. It's including the service connection details. So next is save and run, and you run it, and the build project the build stage and deploy stage was both successful. So this is it. So this is the build job and the deploy job, which were both successful. So a thing to note was, for this deployment, I made use of a default pool. That is to say, I had a self-hosted agent to serve as my pool, which means I create a personal access token under the settings, agent pools. I created the default one. This is my PC, with which I used. It's currently offline, so it actually listens for service connections. So these were messages informing us that, oh, the deploy job was completed, and we had the deploy job completed with success here, and we also had the build job which was completed successfully. So here you had some time with which there was a queue as a waiting because we can't run parallel jobs. So we needed to wait for some certain time for after the completion of the build job for the other one to pick up and was done. So that was that. So, and this is just a screenshot of the self-hosted agent, how it was created using the Azure pipelines. So and this command run set is run. So a good explanation into this is found here, and following all the links specified here, we'll be able to get around this. So in essence, also there was a problem encountered called SCS certificates and permissions on my local host during the build process, because we needed to automatically access some things. And so in short, I had to I had to set a permission, unrestricted permission. Formerly it was restricted as seen here. So I'm sorry, undefined. So for the current user, so I had to make it unrestricted so that all communications with my local PC during the build process could proceed without error. And in the end, we have this page showing the build stage and deploy stage successful. So the project was successful. So thank you for the time and listening.